Right, so the next set on a new box of sets. Looking at the address on the box that they actually came into the previous person, so whether or not he works up there, I don't know. It's Homefirth, so last of the summer wine filming area for those of you who had a television 20 years ago, like I did until 20 years ago. So we've got a Uniden 100. It came in a leatherette case in lovely condition, considering it's 40 years old. And he says in his letter that it works, but will I check it over? It's come with a replacement coffin mic, and yeah, that looks all right. So we'll put the soldering iron on because we'll need to unsolder the speaker, and we'll pop the screws out. And we'll need to change those 4 capacitors that always need changing. But you never know, they may have already been changed, so I won't bother taking the other lid off until I know that they need changing. So I went to the trouble of taking the bottom of the other lid off, they'd have been changed, wouldn't they? I'm going to put a knot in the one which is positive, and we'll see whether it really is positive when I come to put it back together. Not that it matters. So, for those of you who don't see all the videos I do, what's important on this chassis, whether it's under the audio line, the Uniden or the Realistic brand, whether it's the bigger one with the 4 knobs or whether it's the smaller one with the 2 knobs, is that there are now 4 capacitors need changing on site. They go short circuit, and one of those things would be no display, and other things like ruined audio chip, which are expensive. I did buy some for about £6 recently, but I've also paid 15 for them, so you don't want to ruin them. They're made by Fuji, which is not one of the usual kind of manufacturers. Not Fujitsu, but Fuji. So you've got a 220 microfarad one there, the 220 microfarad one there, 470 microfarad there, 470 microfarad there. They all need changing. So I tell you what, we'll just check the radio works. Only because I want to write down how it's working as I kind of take it out of the box. So we'll make a note of that. So we've got a before and after, because nothing worse than sending it back and it's actually worse. I was once in a shop that repaired motor car starter motors and alternators on Carlton Road in Nottingham. Because when I did my organ building apprenticeship, I was just off Carlton Road at Henry Groves and Son Limited, Church Organ Builders, who in those days were at Leighton Street. I think the building's still there, which was a former school gymnasium, and I think has now it got empty. Groves moved to custom premises, and I think that building is now being burnt out by silly people. What a waste. Right, so we'll get this connected to our crocodile clips. And so I was in this alternator repair workshop, and at the time I had a Datsun 720 pickup truck. I was doing scuba diving as a hobby when I was in my 20s, and it was very useful to shove the diving equipment in the back. Anyway, I went in there because the starter motor was playing up on this pickup truck. So I took it off, and I went into the shop with it, and I said, "Can you sort this out for me?" "Yes, certainly. Give us 3 days." And so that was that. While I was in there, there's a gentleman came in with a starter motor, an alternator, one or the other, I can't even remember, and he was moaning that it still wasn't working properly. And he says to them, "You fixed this worse." I think that's fantastic. To fix things worse. Brilliant. So we'll put the power supply at 13.8 volts. We were previously doing a 12 volt radio, so we've done that. The radio's lit up, and it's on that channel which is unusable, which is 19. Unusable because it's full of wallies. Certainly is in this area. And they're 35 miles away. The wallies were here. I'd love to know why they can't change channel these days. You know, it used to be 19 for such and such. Yeah, got you. Knock it up one, or go on to such and such a channel. But, oh no, they have to just talk on top of each other. No doubt with their bigger and bigger burners. Right. Let's get a piece of paper. That's something we should have. The printer's good at churning out bits of paper. I had a query from a customer, and he said this wire's not connected. I said, before you worry about wires being connected, deal with that capacitor, which the heat shrink tubing's retracted on, because that's been overvolted. He says, "Yes, Mr. Holmes." So there's none of that kind of problem on this one, so it doesn't look like it's been overvolted. So Uniden 100 in my bestest, worstest writing. My teachers at school said, your writing looks like it's a spider crawling all over the page. Another teacher said, your writing has gone from bad to worse. Well, can you see how bothered I look? Yeah. I might have to turn the background music down. I normally have the tannoy speaker in here on 1. Oh, yeah, Mr. Chippy's here. Can you just turn my tannoy speaker down to 1, please? Yeah. 1. No, that's it. Thank you. Did you want to have a discussion?
Yeah, when you're done.
Oh, right. I think we're doing another video, and it's on a transistor radio, so I don't know whether the transistor radio is going to hit your screens before this Uniden 100, but it is as a spoiler alert, it's a Roberts R703, 707 with one of those Mullard modules in it. Mr. Chippy is going to do things with it. I'm going to pause the video and we'll deal with Mr. Chippy's requirements. Right, so having dealt with Mr. Chippy's transistor radio requirements, we will do the tests on this radio. So we'll put picture in picture on. There we go, and I'm on the 3 watt scale. We're at 13.8 volts, so we'll key it up. Gone beyond full scale deflection. It's doing 3.5 watts. And on low power, doing 0.35 watts, which is 10 dB. Great. We'll worry about what the meter shows when we do the alignment. So these radios we can't adjust whether they're on frequency or not, because in the manufacturer's infinite bizarre wisdom there's no trimmer. So you have to hope that the crystal's still going to resonate somewhere near, otherwise we have to change the crystal, simple as that. So we'll now go over to, where's my remote gone? It's there, to the frequency counter. This will not alter unless we change the crystal. 2779020. It's not ideal. See what that's like later on, because this radio and the test set's only been on 20 minutes. So at the moment it's 2779020. I would like that to be, because it should be 2779125, and to be honest it really needs to be, I would really like that to be 2779085, really. So we'll see. I want it as close to that as possible. That isn't good. So we're going to set the, to be fair, we're going to set the frequency counter. What am I talking about? We're going to set the signal generator to being off frequency, because at the moment it's set to 2779125. So we'll just pop it down off frequency, so we're giving it a fair reading. And trying to get this to go down a little bit was not easy. So we've got that now matching, which is good. So look at deviation. We'll go back to that on the meter. Wallow. Oh, why am I not getting anything? Let's have a look. 1 2 wallow 1 2 wallow 1 2 1 2 wallow. It's pretty well spot on. It's about 2.5. I want to just drop it a fraction. So that's nearly there. Bear in mind these are always a bit bassy, and it might be a matter of finding a mic that's a bit more trebly. But we'll see what that sounds like when we do the on-the-air test. So next we'll look at the receive sensitivity. So I'll plug the test equipment into the extension speaker socket. It's one of these. That'll do. The one that says extension speaker. Why am I getting no audio? Because I still didn't see it right and put it into the PA one. You tell you, when you get to 40, you know, you start to be needing various pairs of glasses. So at 59, I'm well onto that one. So we're looking at the Synad meter now. So these aren't as sensitive as cybernet sets usually, which is probably why they were better at bleed over. So at the moment it's absolutely fine. It's 0.82 microvolts for 12 dB Synad. Just for the laugh, we'll do 10. So it's 0.78 microvolts for 10 dB, and we'll see if it will do 20. Not all sets will. It will do 20, and it will do it at 2.4 microvolts for 20 dB. All that means is there's noise. It doesn't really mean it isn't sensitive. Okay, so that's tested the radio as it's arrived. So the next thing to do is I'll change those capacitors. I've been over to stores department. There they are. They are different voltages. They remember at the factory they're putting 16 volt parts in. We're putting 25 volt parts in, because the difference, it might be point something of a pence, but when you're making 10,000 radios, it makes a difference. It doesn't make a difference to us when we're doing the repairs, because that point something of a pence just doesn't matter. So we'll pause the video. I'll change the parts. Okay, so we've actually got the genuine realistic manual today, which we always use. We usually use a scan of it. I don't know why we've got this, but we have. And let's look at what the spec says. So the limit spec says 3.4 watts, while our radio is doing 3.5, so that's fine. Let's have a look at the sensitivity. So they want it to be 0.5 microvolts for 10 decibels Synad. We had 0.78. The limit spec is 1, so we're already within spec. And let's look, see if we can see where the frequency situation is. Did they mention the... I'd have to work that out. It's 0.005%. So we'll see what that's doing when we come back to it. Okay, so first of all we're going to do the VCO on it. I've no reason to suspect it's out at all, because it's not really been a set that's been messed with. I'll just put that back to camera 1. Get the famous Aldi multimeter out. Somebody says to me, why don't you use a Fluke multimeter? Or why don't they use an Avo 8? You know. What a stupid question. I once bought a £2.99 meter off AliExpress. I wish I knew where it was. And again, it's quite adequate. You know, you don't need to have elitist test equipment to do these kind of things. We're not setting up a spaceship where things have to be calibrated just so. So here we go. So it's the 2001 model, and we're looking for test point 1, and I can never find test point 1. It is resistor 52. Resistor 52 is just there. So between the two capacitors is a resistor poking out, and it doesn't have any paint on its leads, whereas the other ones, which are vertically mounted, unless the test points, do have paint on the leads, so it does stick out. I can't remember whether this is a floating chassis or whether it is negative earth, so we'll just put the negative prod on there, and we'll just poke our other test prod on there, and we've got 13.66 volts. So that'll do nicely. And so what's the procedure? We'll go to channel 40, and we're looking for what? So it says transmit mode, so we're in transmit. Interesting, I'm not in the right mode on the test set. So it should be 3.5 volts plus or minus 0.1. Well, you know what? That is, to be honest, it's near enough. So then we go to channel 20 on receive, and they want maximum output on the oscilloscope. Well, we'll do that with the synod meter later. So I will just want to know, because it's not in the manual, but I want to know what this is on receive. I'd expect that to be somewhere around 2.2. And on let's look at channel 1, transmit 2.4. Anyway, it's in log. So we'll put that away. And here we go with the rest of it. Receive. It's L5, L654. Oh, we're not doing receive first. Who would do receive first? Transmit 16, 15, 14, 13, 12, 10. I can't even find the page with the... There we go, 2001. So it was 16, 15. What they actually want you to do is to, at that point, monitor with test point 2 and an oscilloscope for the maximum reading. We just don't need to do that because the test set I'm using, Marconi test set, is sensitive enough for me to see the difference between when we do 15 and 16 and 15. So I don't. This is why we have these test sets on all the benches. We've got 3 of these Marconi ones, and we've got a Farnell one, we've got a Schlumberger one, and so it goes on, or whatever it's pronounced. So and we've got something called a quartz lock, I think, as well. So 16, 15, 14, 13. 10. So that's it. So into transmit we go. Put the radio back on high power. Now it will drop down as the radio heats up. So we're just over 3.4 watts. So that is peaked. That's peaked. That's peaked. So what we've gained here is, with it being on transmit for a couple of minutes, of course, as I say, the transmit power drops. So it's dropped to 3.4, but we do now have 3.5, which is where we started. And now they didn't say to do that one. So that's probably the that's 12. That's 10. Oh yes, they did 12 and 10. Yep. I was just wondering if it was the trap for second harmonic, but not so. That was already at peak. And that brings it up to a full 4 watts. I just went beyond and it went up to 4.1. So there we go, that's that done. Out of interest, I wonder where the transmit frequency is at the moment. We've now had the test equipment on for about an hour and we've had the radio on for a similar kind of time. Okay, so we'll switch to the frequency counter to see where that is out of interest. Yeah, it's still lower than I would like. Right, so next we will do what? VR4 for 0.4 watts. So we'll switch to low power. So that's now 0.25 watts. That's strange, isn't it? It helps if I put the right meter on. 0.25. Bit dirty, I think, that, so we'll just waggle it around, put some service oil on it, switch cleaner and waggle it around a bit, and there we have 0.4. Very useful feature, and I miss it on sets that, you know, more modern sets don't have. It wasn't a requirement. It was when you were using it as a base station, your area was above 7 meters from local ground level, they expected you to adjust the power and knock it down to 0.4 watt. I don't expect many people do, but in a car situation, if you're in a convoy, instead of blowing each other's windows out, it's much better just to have it on 0.4 watt. So there we are. We've got full 4 watts on. It might be even 4.05 now that when it's cool. So the meter, we want it to read what? It's the blank zone between the green and red on transmit. So VR3 is that one. In fact, we want it in the centre of the strawberry patch. What they're telling you is it should be just there. But in fact, we want it in the centre of that red zone. So that's a bit of bull. Deviation. Now we were correct. It was just about correct. It just needed to come down a little fraction. And it's preset VR5. So VR5 is going. I was expecting it to be there somewhere. Oh, it's there. It's hiding, isn't it? So get the little oscillator out. There looks right there. 1 2 wallow, 1 2 1 2. I think we'll leave that exactly as it is. Let's just see what it listens like. What it sounds like. Testing 1 2, testing 1 2. Yeah, as muffled as you'd expect. Okay, so they want you to set that to 1.9 deviation, but you need to set it to 2.2 with an absolute maximum peak of 2.5. Otherwise it'll be too quiet. But not as quiet as modern sets, which are set at 1.4. So what do they want you to do next? That's it. We've covered that. We've done everything. So let's go over to I'll tell you what, we won't go over to receive. We'll do something about it being off frequency. So I'm going to see if I've probably got a duff one somewhere we can nick a part out of. Not sure we want to nick anything out of that. It's that looks more or less complete, doesn't it? It's our own set. That one. We're not going to scrap that one. We actually do need a crystal from somewhere, and I don't really want to put a new one in. I'll see what I can do. I'll pause the video. Well, unbelievably, despite it looked like it hadn't been messed with, it had an illegal modification. The public address switch has been disconnected. I'm going to have to put that back right. So we'll have to open up another set to see how that wiring's done, because we're using the realistic manual. It's obviously going to be different in those kind of respects. I think when you press the PA button, it took it between channels or something stupid like that. You know, it really does annoy me. So, in actual fact, there wasn't anything wrong with it being off frequency. It was illegal modification which was making it off frequency, even in its normal mode, in inverted commas. So, yeah, it's slightly down. It's 2779109. That's fine. That's well within spec. So, the trouble is, it takes longer to start working out and undo these modifications than it does to actually do the repair. And it also takes us into our next tariff. So, you know, it's like doubles the price for the customer, which isn't good. And we're well out of pocket, because it's a lot more time than we're charging for. So, it's actually now 2779109, which is fine. So we've now got that as 4 watts. We've now got that at 0.4 watts. That's correct anyway. So now we'll work on the receiver. So we'll reset the signal generator. Where are we? Put it on the frequency counter. So 79. I will set it as this. It's slightly low, isn't it? So we'll set it. We'll set it to 115. It's just so we're not tuning the receiver lopsided. When it's actually presented with a frequency which is correct, it will still work properly, but I don't want to tune it lopsided. Now then, did I just watch my trimmer fly off? No, I didn't. So the first thing we're going to do is to set the detector L19, and L19 is just there in insulation tape land. So switch the oscilloscope on, switch the camera to the oscilloscope, turn the bench light off like I've just done, put an S9 equivalent signal on of 100 microvolts. Yep. And we want maximum recovered audio. So the oscilloscope's just across the extension speakers, nothing clever. Very, very basic oscilloscope, all that's needed. Miles out. I bet that was distorted. Okay, so now we're going to go over to the sine nav meter. We'll put the bench light back on. Anyway, I'm glad I didn't have to change the crystal, because even to sell, if I was generous and sold him a second-hand one for a £5, it's still stuff we could ill afford to sell on. To be honest, we need all the parts we can retain, and to have crystals custom made these days is £35 a piece. So let's get that down to about 4 dB so we can actually see something meaningful. And let's see what order we're doing this in. It's 6 5 4 3 2 1, and then we will just check that. I think it was that one. We will just double check. 6 5 4 3 2 1. So 6 5 4 3 2 1. 6 5 4 3 2 1. I honestly don't think that's the ideal order. I'm going to do them the other way around because that's the front end. Got a slight improvement there. We can drop the attenuator a bit. You're always backing that attenuator down. Says me showing you the wrong thing. So L2. It's worse. That's quite an improvement. Now we'll just go back on the first one. They are interactive, and we'll drop that attenuator again. Again, we've pulled quite a lot back there. Double check the previous one. I've said many times before, they haven't got time at the factory to set these up. They'll just peak them once, won't be going backwards and forwards like me. It will reach a line on a test instrument, and on the conveyor belt it goes. Now the next ones, we're normally going to use a higher signal. The part of the IF, we'll just do that. And that's one. Okay. Let's see what we've got now. So, the 12 dB which we check, our little benchmark, is now, you know, after all that work, it's now 0.78. Mind you, that could be, I was a bit over 12 there. That's nearer 12. It's 0.75. So that's 0.75. Fine. Not then the 10 decibel one, which is the one that they say in the manual you're setting it for. There's 10. It's now 0.64. So that's nearer the 0.5 that they would like it to be. And then, just for our own entertainment, we did the 20 dB one. See if we've got any improvement there. 2.4, it's just the same. That's all down to noise. But, you know, if you changed every capacitor in it might bring that up. But it's not really of any benefit. Yeah, it's 2.4. Yeah. The only thing I haven't done is we'll just check whether that. I'll just go back on there. It's L18, L18. Just check that we've got the maximum coming out of there. In fact, we've just gained a bit more. So rather than doing that early on with the oscilloscope like they say, we're doing it with the synod meter. So perhaps I better just check where we are with 12 dB now. So there's 12 dB. So we're now at yeah, it's still at 0.75, and 10 dB 0.64. So no, it hasn't changed anything, but it did bring it up that little bit, so that's good. So we're going to go to S9 equivalent. So we'll put it on, I think we'll put it on the attenuator now. So 100 microvolts on there. So what we're looking for is S9 on the meter. You know, it's virtually spot on, that. And it's only very arbitrary anyway. What's it matter? And I was talking to someone in amateur radio yesterday. Strangely enough, 2 meters. I don't often use 2 meters. So that's the 145 meg band. And the gentleman was on a walkie-talkie in Wales. And I'd gone to a high point with my radio van, and I was using a 10 watt radio, and I think I was giving him S2, but it was readability 4, readability 5 even, I can't remember. But he was talking to me on a handheld 5 watts from this hilltop in Wales, so probably 200 miles away, and he was giving me S nothing on the meter, you know. So it was still radio 4 and a bit. It was just a bit of surface noise. It was absolutely cracking contact. It really was. But it didn't need to move the meter. It's not about that. It didn't matter. But some people, oh, you're not giving me the same as I'm giving you. Yeah, right. So what we're doing. It's variable resistor 1. That's that one. And we want that just a fraction higher. So, where it says 9. It was like 8 and a bit. So now it's 9. But really, we could probably put this on another test set and it would be slightly different, because there's going to be a tolerance. Now, the Squelch is something which is dear to my heart for FM systems. So I'm going to put the set to full Squelch. We're going to turn the attenuator, because I want the radio to open on full Squelch as 100 microvolts. What do they say? What do they say? Set the signal generator to 1,000 microvolts. You know, no, it doesn't want to be as coarse as that. But there you go. So 100 microvolts, 3, 10, 30, 100. Just for the laugh, just for the giggle, we'll put it up to 300 and 1,000. It doesn't even open as 1,000, so that's been screwdrivered. So we'll unscrewdriver that. Hopefully. You know what? It doesn't respond. It's because I'm on the wrong setting, aren't I? Right, let's see if we can get this Squelch to open and at what point. So I've gone and turned the wrong preset. So I'll have to put the signal meter back right when I've done. It's that one. That's the most sensitive it will go, and that is not why I like it. 1,050 microvolts. Anyway, that's how it is. That's on the least sensitive setting. Now, the other side of the Squelch sensitivity, let's just turn it down to nothing. Turn the signal generator. I've parked it at 0.3 of a microvolt. We'll switch the signal generator off. We'll set the Squelch threshold. Switch the signal generator back on, and let's see where we can come in with this signal. So it's coming in at 0.95 microvolts. It's dropping off at 0.85 microvolts. So I mean, I like squelches to be a bit more sensitive. I wonder if we can really, really carefully set the squelch threshold again better. You wouldn't be able to do that in a car. So we've now got it coming in at 0.8, leaving it 0.65. So you can do that. So it'll certainly be alright at Scratchy Corner when we do our test. So I just need to go back on the 100 microvolts and reset the meter, which now reads S4. Put that back to S9, just like that. And the set is now done, but we've got to find out this silliness to restore the public address feature. It's like going to tune an organ, isn't it? And it's got two keyboards, and well, we never used the top keyboard. Yeah, well, I'm still going to tune it, aren't I? You know, so it's got to be right. So we'll pause the video and let's see if I can find another set and copy the wiring. Job 50 minutes to do the radio, and then about an hour and a half to put the modification. But I've had to dig out another Uniden 100, found out what the wiring is, and so it's just for those people who need to know, like we'll need to know if we ever see this again. It's the two which were still on were yellow and orange, and then it's grey, red, brown, blue and white, and then your black one goes there, which was on the top on this set. So we'll put all those back, and then we'll solder it back onto the switches. Okay, so that's done. A lot of faff. I put the other set away, and we're in PA mode. Do we turn the volume down there? No, we don't. Don't know how you do the volume on these. Anyway, that's how it is. That's now working. Go back to TB, and it's working on there too. Just make sure we can hear something. Oh yes, we have to plug the speaker into the other one. There we go. Good, so that's now finished. So I'll turn the power off. We'll just check that the one with the knot in it was positive. I say it doesn't matter, but in actual fact it's negative. It really doesn't matter about polarity unless you start having stereo, you know, where things would be out of phase if one speaker was working one way and the other speaker working the other. So the one with the knot in is in fact negative, and we will solder that back on. And negative is the one further away from me, to the left. Just put some solder on. Notice it's a 16 ohm speaker. And let's see whether the speaker actually works. It does. Good. Turn the power supply back off. So once again, I'll pause the video, put the screws back in, and we'll plug it into the aerial. Alright, so let's put the power on. We're on the aerial. "19 Roger." It was about 6:30 on a Sunday. Probably about 40 miles away, those we can't hear. No. Anyway, we're doing on the air test with Mr. Chippy, and he's turned the radio into a nice radio. Now, had it not been off frequency so far, I wouldn't have noticed that had that illegal modification. And of course, as ever, it's illegal modification which was stopping the radio from working properly. So there you go. That's what happens. I've forgotten how he acquired it. It's come somewhere down the line. So anyway, that's the Uniden Uniace 100 from 1981. Back in the land of the living and working beautifully. Full 4 watts output and jolly good receive too. Thanks for watching.